One of the basic properties of a lens is its focal length. And so on websites, you will often see the focal length featuring in the title of the lens. So this is a Canon 50mm lens, an 85, an 85, an 85. There's a lot of 85s. This is 65. Um, what is focal length? So focal length, and I've got everything written down. This is all you need to remember from this video. So what is focal length? Focal length is the distance between the rear principal point or the nodal point and the center or the film plane when you have focused the lens at infinity. That's that's just the definition. And you can check that in uh, on a website such as Photons to Photos. You go to optical bench, and then if you're lucky, your lens will be. It's a huge list. They have a very long list of a lot of lenses, and so probably your lens is one of them. And so what you can see here is this is for the Canon 50mm f1.8 lens. This is the design, the optical design. So you've got 1, 2, 3, 4, 5, 6 lens elements, probably in 1, 2, 3, 4 groups. And what they're doing is they're using ray tracing to determine that um, rear nodal point, because the sensor or the film plane, that's easy, right? That's this vertical line indicated by I. But where is that principal point or that rear nodal point? Well, using ray tracing, you can actually find that, and you don't have to do it yourself. This software will do it for you. Um, and so all you have to do is you have to click on principles, and you will get actually two principles. You get H and H prime, and the H is actually for German. So in German, they call this not the principal point or the nodal point, they call it the Hauptpunkt, so the main point or the head point, whatever. And what you're looking for is H prime actually. So this red dot, the distance between this red dot and the film plane or the sensor plane, that's your focal length. So you can, well, you can use a ruler, and the ruler starts at 0. It lines up with the front of the front lens element, and you can kind of see where those 2 points are. But you can also look at the positions. That's much easier. So H prime is located at 21.58 millimeters, and the image is at 73.15. So you take a calculator and you do 73.15. You subtract 21.58, and that gives you 51.57. So that is the measured focal length. So you see focal length specified 51.6, measured 51.57. So that's very, very close to the specification. So that is just technically the definition of focal length. So focal length doesn't have anything to do with sensor size or anything like that. It's just these 2 points and the distance between those 2 points. So what does that mean? Because um, this is just a technical thing, right? So why should we care? Well, for photographers, it means a couple of things. It means, I think, 3 things especially. Magnification. A longer focal length will give you more magnification. So an 85 will give you a greater level of magnification than a 50. It will also affect depth of field, with longer lenses giving you less depth of field and shorter lenses giving you more depth of field. Of course, you have to keep the 2 other variables the same, the aperture and the distance between the camera and the subject. Because if you look at the formulas for depth of field, you will see that there's 3 things um, impacting the depth of field, and that's aperture, distance, and focal length. And then, of course, we have in combination with a specific sensor size or film size, it will determine the field of view. And a larger sensor or film size will give you a greater field of view. So you will see more of the scene. So that's why This is something that on YouTube you can find a lot of videos about when you switch from a full frame camera to a crop sensor camera, or vice versa. What is the quote unquote equivalent focal length, right? So this is trying to keep that field of view the same. So if you're used to shooting um, on a 50 millimeter lens on a full frame sensor and you switch to crop sensor, you should probably also switch to a 35 millimeter lens to keep the angle of view or the field of view the same. Anyway, so that's what it means. Magnification, depth of field, and field of view if you combine it with a specific sensor size. So let's first take a look at magnification. So let's go to Photoshop, and I've got two images, and they were shot on the same camera from the same position. And unfortunately, I wanted it to be the other way around. On the right, we have a shot taken with a 50 millimeter lens, and on the left, we have a shot taken with an 85 millimeter lens. So essentially, all that changes is magnification and depth of field. So if you want to know about magnification, so this is shot with a Canon EF 50 and this is with an 85. So the 50 is actually a 51.6 millimeter lens or a 51.57 millimeter lens. And the 85 f1.8 is actually an 85, a real 85. So it means that magnification, if you do 85 divided by 51.57, that's about 65% bigger. So the 85 millimeter lens should give you an image of the subject. Let's say the building is your subject. That should be about 65% bigger than the building on the using the 50 millimeter lens. And these are not crops. These are actually just the way they were. Um, so if you want to measure that building, let's go, just let's line this up a little bit. I'm gonna measure the vertical distance. I'm gonna line this up a little bit. So I'm just going to measure that distance. Let's clear this for a second. So I'm just going to take connect. Yeah, so that is 1616 pixels, and then here we have let's get this. You see, I'm not very good at doing YouTube videos because I'm doing this way too slow for most people. Did you hear that sound? Don't know why that is. Okay, and so that would be, do I still have the ruler? Yeah. Did you connect there? Okay, so we had, let's take a look. What's the length? Doesn't say it, that's strange. 1616 and okay, 996. So 996 and 1616. Should have done it the other way around, but that's about 62% bigger. Yeah. So that's what we had when we did 85 divided by 51.57. Well, give or take a few percentage points. So that's just what you get. You get a larger image, and that's pretty much it. So magnification is one thing. The other thing is depth of field. So if you look at, let's see if we can do that. Zoom out a bit. So depth of field. So if you look at this part of the image, you see with the 85 millimeter lens, this is not sharp. Of course, the house is, or the building is sharp. It's not a house, it's a restaurant. If you zoom in to the same woodwork, you see that with the 50 millimeter lens, it is in fact, it's not super sharp, but it's sharper. So you can probably see that this is not sharp. Well, if you zoom in enough, it's always gonna, this is 200%, let's go back to 100. So it's bigger, so at 100% it looks bigger, so that's your magnification, but also it's less sharp. So that's just what it is. You get more magnification with an 85 than with a 50, and you get less depth of field. Of course, the building itself will be sharp in both images. But it doesn't do much else, I think. So in combination with the sensor size, yes, of course, this is both, of course, shot on the same camera, so the sensor size hasn't changed. So you see more with the 50 millimeter of the scene. You see more of this tree to the left. You see a couple more trees to the right of the building. So that's just what it does. It doesn't do things like, sometimes people say that it gives you lens compression, which I think is more of a perspective thing, and perspective isn't governed by focal length. Perspective is your distance to the subject. So if you go closer, perspective becomes more exaggerated. If you move back, perspective gets less pronounced. And actually, the perspective between these two images should be the same. So you can actually do that. So let's say you have, let's do a stamp visible here, and then let's move that layer over into this image, if I can. Did it work? I don't think it worked. So I want to move this to, okay, now it's worked. So let's make this one image. I wanted to clear the guides. So let's put this here. Okay, so we have a layer that is the 50 millimeter layer, and then underneath it's the 85. So in fact, if you would magnify this in post by about 62%, I think we had. This is 64%, but that's just the lens focal length. I think we had 62%. So let's do Control T. Let's link that, and let's do 62% bigger. And I think it should be, okay, enter. Well, it's not aligned, but you can probably already see that it's pretty much the same. Okay, let me try to align this. Again, this will go pretty wrong. So about here. I think I also have to rotate it to some degree. Well, it's pretty hard to see, but let's see. So it's not a perfect alignment job, but you can probably see that this is, whether it was the 50 millimeter lens or the 85, you're getting the same. Oh, let's do a little bit of a better job. So let's, okay, that's probably better. But you can see that the relationship between the near and the far objects are pretty much the same. So there is no lens compression or difference in, perspective between these two photographs because I didn't change my position. But what you see is, of course, the depth of field thing that I already mentioned. So here with the 50 millimeter lens, it looks pretty sharp. If I look at the 85 millimeter lens, that looks less sharp. I don't remember what f-stop I used here. I can probably look it up, but it's probably a 5.6 or f8 f-stop. So that's it. So let's see if I didn't miss anything. So what is focal length? Okay, we know what it is. And it gives you magnification, depth of field, and then of course, in combination with a specific sensor size or film size, it gives you specific angle of view or field of view. I think that's pretty much it. For me, at least in my mind, these are the main points to mention with respect to focal length. If you have any questions, feel free to leave them in the description, not in the description, in the comments below. If you have any comments, same thing. If you have any other things that you think are important to mention for focal length, please let me know as well. Okay, that's it. Thank you very much for watching. See you next time. Bye bye.